Following is Group 5's presentation on wireless marine communication. Various objectives were covered during the course of this project. The marine environment is defined by an open space with very few obstructions. It facilitates long-distance communication, but the Earth's curvature is a major limiting factor for long links. The ocean surface is highly reflective, and wireless signals propagating in the atmosphere are subjected to significant refraction. Thermal noise is the main source of noise in this environment. Of the models investigated, the most suitable were determined to be the ITUR and Longley-Rice models. Both are applicable over a large range of frequencies and distances. Both are intended for use over sea paths by considering various environmental factors as well as the Earth's curvature. The ITUR model also takes into account various antenna parameters, whilst the Longley-Rice model considers both the nature of terrain and antenna, the dielectric conductivity of the channel, as well as time, situation, and location variability. Now, various factors affect the maximum link length of the communication link. The major fundamental limit considered for this project was FSPL. Practical limits include parameters we can manipulate to overcome fundamental limits. The maximum link length is also governed by various quantity and quality requirements or application-based link requirements. For the design communication link, the most limiting factors were determined to be FSPL, SNR, and antenna height. Substituting the given Wi-Fi parameters into the link budget equation yields the FSPL for uplink. Based on the given frequency specifications, the maximum uplink length is determined. The next step is to repeat the process to determine the maximum downlink length. The smaller of these two values yields the maximum link length as limited by FSPL. Similarly, by substituting the given parameters into the line of sight equation, the maximum link length as limited by antenna height is determined. In this case, the uplink and downlink values are the same. To determine the maximum link length as limited by SNR, the first step is to calculate the thermal noise power. The received power is then determined by substituting the noise power along with the minimum acceptable signal-to-noise ratio into the SNR equation. The link budget equation is then manipulated to obtain the corresponding FSPL and subsequent maximum link length. In this case, the uplink and downlink also yield the same result. The most limiting factor of the three was determined to be antenna height. A summary of the theoretical results is illustrated here. Now we have the simulated uplink results. The simulated uplink maximum length was determined to be 13 kilometers. Here we have the simulated downlink results. The maximum downlink length was determined to be 12.48 kilometers. Hence, it is seen here that the simulated maximum link length was determined to be less than that of the theoretical. This may have been the result of Radio Mobile's implementation being based on the ITS Longley-Rice model, whereas the theoretical analysis was based on the free space path loss model. Based on the maximum link length and capacity obtained, this suggests that Wi-Fi is suitable for use in the marine environment. The optional use of encryption services also supports its viability for safety applications. However, there are various practical limitations for use of Wi-Fi in the marine environment. There are ways to overcome the various limitations. Increasing transmitter and receiver heights can increase maximum link length, as the most limiting factor was antenna height. In addition, once it is ensured that the minimum SNR and receiver sensitivity are not exceeded, transmit power can be reduced whilst maintaining the same maximum link length. This will result in a reduced channel capacity, but since the channel capacity at maximum link length was much more than that required for the application, a reduction of this parameter is a non-issue. Other techniques, as illustrated here, can also be used to overcome the various limitations. Finally, the key considerations when designing a communication link include the various fundamental and practical limits, as well as certain quantity and quality requirements. The channel chosen must also have the ability to support the required capacity. This concludes our presentation.